all right welcome to another video. In this episode we are going to look at how we can talk about this particular limit. All right, this limit on the board looks so simple, but then it's not just simple like that. We have to apply some limit properties. Of course, the identities of trigonometry, they have angle properties. Okay, so here when you try to do direct substitution here, you know that 1 minus cos, when you put 0 here, you're going to have cos 0, which is 1. So you have 1 over 1 minus 1, which is 0. All right, so we have 0 over s squared, and that is 0. Okay, so that disqualifies our proof because we want to prove that this particular limit is equal to half. All right, here you can either use the L'Hopital's rule, which is going to make the work so simple, but I want to use the trig properties. So we all know that we have a well-known identity, right, for limits, right? We know that limits as s approaches 0 of sine x over x is equal to 1, right? We know this. This statement over here means that sine x, right, as s approaches approximately 0, this sine x is equal to x, right? So this sine x is approximately equal to x when x is close to 0, very, very close to 0. Okay, so we have this here, we have this property as well. Now, we have to go to the half angle property in trigonometry. All right, so the cosine property, which is cos x, right, is equal to 1 minus 2 sine squared x, 2 sine squared into x on 2, right here. This property, we want to prove it and use the final solution to do substitution over here, right? So we know that x, right, we want to see how much x or 1 can be very, very close to cos x. Okay, so we have 1 minus cos x, right? So we're going to have 1 minus, whatever you do here, you do same here. So 1 minus into 1 minus 2 sine squared into x on 2, right? So this, when you do this, you're going to have 1 minus cos x equals 1 minus 1 plus 2 sine into s on 2, right? So this basically takes off this, and you have 1 minus cos x equals 2 sine squared into x on 2, right? So we have seen that 1 minus cos x is basically equal to 2 sine squared over x, sine squared x on 2, right? So we do this substitution over here, right? Because you want to have something to have in a form of this limit, right? So we have this limit as s approaches 0. We do this substitution over here, so we're going to put 2 sine squared into x on 2 all over x squared, right? So this we have right here. We have to express the denominator to look to behave as a standard limit, right? So we change this denominator right here. So we know that limit, or let's consider the s squared. right? S squared is equal to, is the same as 4 times x on 2 all squared. You know why? Expand this, going to have s squared on 4. Basically, this goes off. So this is equal to this. So we substitute this into this. So here we have limit as s approaches 0, 2 sine squared into x on 2 all over 4 into x on 2 all squared, right? So this we have right here. We can see clearly that this is basically lim as s approaches 0, 2 times 1 on 4, right? Times sine squared into x on 2 all over x on 2 all squared, right? So this expression we have right here is having some image here, right? So we say that limit as s approaches 0, this becomes half times, this can be expressed as sine x on 2 all over x on 2, right? So we have this here. This is basically 1, right? From here. Okay, so we say that limit as s approaches 0, half into 1 squared, right? And that is equal to limit as s approaches 0 of half, right? So basically we know that limit of a constant is the same constant, right? So clearly we can see that limit 1 minus cos x over s squared is basically equal to half, hence proven as we can see over here. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye bye.